Hi, my name is Andy Danison, and I'm a second-year PhD student working with Dr. Eric Snively, and today I'm presenting some of our research titled A Full-Body Biomechanical Model and Novel Forelimb Muscle Forces in Tyrannosaurus rex. Starting off with our introduction, when we're dealing with extinct organisms, sometimes biomechanics is our best bet for inferring what these animals were doing when they were alive. And one of the most popularly used methods of doing this is muscle reconstruction, which is when we look at the fossil record, specifically rugosities on the skeleton called muscle scars, that denote where muscles would have attached when the animal was alive. Alongside phylogenetic inference, which is essentially looking at the soft tissue of the closest living relatives of extinct animals, this provides a rigorous framework for reconstructing the soft tissue of extinct taxa. Previous analyses have actually created 3D models based on these reconstructions to estimate the physiological cross-sectional area and calculate the corresponding maximum contractile forces using these two equations right here in order to draw conclusions about the capabilities of these extinct organisms. We specifically are interested in applying these established methods to the forelimb musculature of Tyrannosaurus rex, as the function of T-Rex's forelimbs has remained a mystery in the paleontological community for almost as long as they have been described. Also, we have generated a full body model of Tyrannosaurus rex's muscles using these same methods in order to calculate the forces behind full body movements. So our objectives for this study were to specifically estimate the maximum contractile forces for each humeral protractor and retractor muscles. Those are the muscles that are moving the entire limb forward and backward, and make functional and behavioral inferences based on our biomechanical model. And finally, create an atlas of Tyrannosaurus musculature for future research and education. Moving into our methods, first, we created digital models of a T-Rex's skeleton using photogrammetry, which is essentially taking a bunch of pictures of a specimen like a T-Rex skull and actually stitching that together into a 3D model. After that, the muscles were sculpted around the model using Autodesk Maya before we were able to measure the lengths and volumes of these muscles and plug it into those previously described equations in order to calculate the maximum contractile forces for these different muscles at different fiber lengths. Here you can actually see the pectoralis muscle, which I have a model of right here, which I think is very cool. Moving into the results, here, this table shows the forces associated with the humeral protractors in green and the humeral retractors in red. And you can see that these forces are quite high. So if you are not familiar with newtons, these translate to around 800 pounds of force on the lower end to around 2,500 pounds of force on the higher end for both the largest humeral protractor, the pectoralis, and the largest humeral retractor, the latissimus dorsi. Moving into our discussion, these very high muscle forces, surprisingly high muscle forces, and show that T-Rex was capable of very powerful forelimb movements. And this has some important implications for how Tyrannosaurus rex would have used its arms, which has been that big mystery that we described earlier. With muscle forces this high, Tyrannosaurus rex could have easily used its forelimbs to actually secure struggling prey while it was hunting. And overall, this model provides some novel force estimates for previously unanalyzed muscles in T-Rex, which is awesome. It means we'll have a very high impact overall. And we are still working on incorporating musculature from all these different regions of the body to allow us to model those full body movements which we were talking about. And here's a really nice picture showing muscles from those different systems together. In the future, I hope that we can actually pair this biomechanical data with trabecular orientation. That would really ground some of this theoretical work, and it would be awesome. We can also calculate muscle moment arms and forces to quantify the torque that muscles can exert around the joint. That will further ground some of these more theoretical muscle forces. And finally, hopefully we can actually establish comparisons between T-Rex and other similar taxa, other big theropods like Torvosaurus and Allosaurus, to get a better understanding of how these traits vary across theropoda as a whole. Thank you for your time, and I hope you have a wonderful day.